Out of memory. So, what is out of memory? And have you faced an out of memory issue? So, this is how the interview question will be. Okay. So, what is out of memory? First, let's understand what is out of memory. The out of memory happens when executors or the driver try to hold more data in memory than available in the JVM. So, usually due to large reshuffles, joins, queue data, or excessive caching. So, this is what out of memory is. So, in simple terms, what is happening is, so let's say you have 100 MB of memory and you're trying to load the data, which is like 120 MB of memory, right? So and you only have 100 MB memory, but you're trying to load 120 MB of memory. So that's where the memory overflow out of memory happens. It basically says, hey, I don't have enough memory here. So that is what out of memory means. Okay. So what happens when you have a out of memory? So your executors crashes, there will be job failures, there will be task retries, and there will be extremely slow performance, right? Because you need some memory to kind of do certain tasks, right? So that's what happens. So out of memory can happen on your executors, they can happen on your driver programs, or they can happen during a shuffle. They can happen during caching. They can happen during joins. They can happen during aggregations. So there are places where you can have this out of memory issues. All right. So now, why out of memory happens, we have seen, right? So let's look at a little bit in detail, right? So there is like too much of data in memory, right? And what could be an example, right? So if we are caching large data sets, okay, now large data sets. So every time you cache the data set, so let's say you have 1 GB of memory and if you're caching 700 MB of data. So that means out of 1 GB of memory, you've already used 700 MB of memory, and then you are only left with 300 MB for all your operations, like reading the data, writing the data, performing joins, all that stuff, right? So that will cause a performance degrade. So this is one important thing you need to always remember, like what is the memory that you have and what is the memory you are trying to cache, right? Uh, Large shuffles. Again, shuffling is movement of data from one mode to another. If you do large shuffling, then obviously that will also cause a lot of issues, right? So some of the examples of shuffling, like if you do a group by, join, distinct, right? So these are some of the operations where you have shuffling. Then if there is skewed data, so one of the partition can be very big, the remaining partitions can be small. That also cause issues with the memory. Obviously, if you have a wrong partition size, like if you have too few partitions, so too very little partition basically causes a lot of little files, right? So that will also cause memory issues if you are doing the wrong partition size, that is right. Um, Wrong partition size. And again, broadcasting. So broadcasting large variables, sorry, broadcasting large tables, similar to the caching of large data sets. If you are, it's very similar, right? If you are if you are broadcasting large tables, basically you are putting a lot of memory already used, right? So, and of course, executors, you need to provide a proper memory. So if you do not have the proper memory or insufficient memory, then that will also cause issues. Serialized objects as well, like if you have objects are very large, that will also cause an issue. Okay. So these are some of the things that can happen when out of memory can happen because of this. And it can happen anywhere, like in joins, aggregation, shuffle, caching, all this stuff. Okay. So now there are different types of OM errors that you will encounter. So the most common is Java heap space. So this is a very common thing that you will encounter. So it basically since the Java virtual machine heap size it's exhausted, right? Then you will have something called as out of memory error, a metaspace, like too many classes, all these things. So overhead limit exceeded. These are all the out of memory errors that you will encounter. So what you need to kind of ensure that this is something that happens. Even if it happens, you can kind of debug and try to see like why where it is happening and take steps accordingly. But it's always better to kind of ensure that you follow proper structure. uh, the shuffling, whatever that we talked about, the shuffling or the partitions, have the right partitions and everything. So it's always better to kind of prevent this than to actually solve, because this can be a very big headache for us to solve the out of memory issues. So how do we prevent the out of memory issues, right? So we need to ensure that we have sufficient memory. That's the main thing, right? So one thing is like there are two ways. If you have a less memory than what you need to increase the memory. So let's say if I have 100 MB of memory, but I my process takes like 200 MB of memory. So this is not sufficient. No matter what optimizations I do, this is not really sufficient. So I need to increase my memory. That is one thing. And if I have sufficient memory, right? If I have 500 MB and all the process takes 200 MB, I need to ensure that my process are optimized. So I do not want to create unnecessary shuffles, or I don't want to create unnecessary partitions so that this memory gets increased to 300 or 400. So those are two things at the code side that you there are few things that you need to do at the code side. At the infrastructure side also there are few things that you need to do, right? So let's talk about the infrastructure, because we talked about the code in other videos as well. So you need to you need to increase the memory, like you need to increase this spark.executor.memory. So these are the configurations that you need to ensure you increase. So there is this will increase the executor memory. You also need to do memory overhead, spark.executor.memory overhead. You also need to increase the Spark dot driver memory as well. So this is driver dot memory. So you have to increase this. So these are at the some of the things that you can take care to kind of ensure that the out of memory does not happen. Or if it happens, then these are the steps that we need to do, right? Okay. Uh, Huge partitions. Use partitions efficiently. Do not use very less partition because it will cause a lot of smaller files. Use your partitions effectively. Shuffling, reduce shuffling as much as possible. So again, shuffling are inevitable, but within the code, right? Ensure that if, for example, uh, if you're using join, and if there is a possibility for you to kind of use a broadcast join, please use a broadcast join so that you don't have to shuffle the data between multiple nodes. So that's one example. Like distinct is another example. Like sometimes the data that we get is not we don't have that duplicates, and you don't have to use the distinct. So often I see people just, that is one of the default thing that you do, hey, select distinct, that blah, blah, blah. But you don't really need to use a distinct. You need to first check if you actually have the duplicates there. If you do not have the duplicates, do not use the distinct because it causes performance issues, out of memory sinks and everything, right? So these are things that you can use. Uh, Again, if you have a skew data, like one of the partitions is having more data, the other partition is having less data, those are the things that you need to also take into consideration. So um, use cache carefully, right? So again, we are dealing with memory. So if you have a very large data set, it is always advisable not to cache it unless you have a lot of data. lot of memory available. So very large data set, do not go for caching only. And also, if you are using the data once, like you created a data frame and you are reading the data frame and you're using it only once, do not cache it. You don't have to cache it. Just because cache is there, you don't use it, right? So there are oftentimes when I review the code, I see sometimes like people just use caching just like that because they think that at some point they will use it, but they don't use it, and they don't go back and remove this code. So that is one thing that you need to ensure, that if you are using the cache, right, and if you are using the cache, ensure that the cache, whatever that you are using it, has some value, right? If it is used only once. And also, once you have used cache, ensure that you uncache or unpersist it, because if you have to release that cache, right? So if you have 1,000 lines of code and you're using cache at 10 different places, uh, let's say at 500 line you are using the cache, and then after that you're not using it, right? So it is always better to kind of release that, right? Uh, and also some of the important things like don't do something like this at driver collect. Don't want to get all that information here, right? So uh, you also need to ensure that this is something which is taken care. Okay, so these are some of the things that you can use or take care to avoid, or in some cases, even after doing all these things, you may not be able to avoid, then you will have to go back and kind of change those configurations like the executor memory and all other stuff. Okay, but this is a good list of things that you can do to kind of avoid or work uh, on the on the memory issues, outer memory issues. Very important question. So I hope you were able to understand this, and I'll see you guys in my next class.